So what we're going to look at now is nuclear fission versus nuclear fusion. When we talk about nuclear fission, this is ones that will occur in nuclear reactors. We can occur this in some types of atomic weapons. What we're doing here is we're splitting up really large nuclei into kind of smaller pieces here. And in the process, we're giving off lots and lots of energy. And a lot of times these are chain reactions here. So it's not just doing it once, it's doing it multiple times and kind of logarithmically here. So we get large elements. Usually what you're going to see here are neutrons being shot at something that's really large. So in this case, like a uranium one, uranium isotope here. And it's going to break down into smaller products. It's actually going to give off more neutrons. And all of those neutrons are going to hit other uranium isotopes. And every time it does this, it gives off a large amount of energy, way more than chemical reactions for these nuclear fission and fusion reactions. So let's take a look at our example here. So uranium-235 is struck with a neutron, and it undergoes nuclear fission. It's going to produce 3 neutrons, krypton-92, and one other mystery product here. We've got to write the equation below. So we've got uranium-235 and a neutron on this one, right? So that is going to produce 3 neutrons. So I could write the neutrons like this. But that gets really tiresome, especially say I had like 6 or 7 or something, like a lot of them. So we won't often see it like that. We'll see it kind of the same way you see it in chem, where you get a big value in front, like 3, to represent you've got 3 neutrons here. Plus our krypton. Find our krypton, 92. Krypton, if I go to my periodic table, is atomic number 36 plus some mystery substance. So I got to do some balancing over here. Right, so if I go to the left side of my screen here, change that color, and add up my 2 top values, my nucleons up here, this is 236. So if I go to the right side, remember there's 3 neutrons. So I go 3 plus 92 is 95. So 236 minus 95 is 141 for my top values. I go to the bottom value here. I've got 92 totaled on the left side of the equation. I go 3 times 0 is just 0, plus 36 for my bottom value. So 92 minus 36 is what? 56? Yeah, 56. And I go to my periodic table. I'm looking up what is atomic number 56, and that is barium. So my mystery substance for this one is barium. If I look at the next one for nuclear fusion, now fusion will occur in things like the stars, our sun, where you get kind of lower mass elements that are on the low values on the periodic table, fusing together, okay? And in that process, they give off energy, actually a lot more energy than you get with fission reactions. So there's a lot of interest in fusion reactions here on Earth. There's some technical limitations we've been running into to try and replicate, because if we could figure out nuclear fusion reactions and use that in our kind of nuclear reactors, one, there's a lot less radioactivity given off, much, much less. And it's a much cleaner kind of source of energy. And we get a tremendous amount of energy. So right now we're mostly talking about on the stars, kind of in our sun for this type of reaction. So what we get here is 2 smaller nuclei joined together. Think about things fusing together to form larger nuclei. And some of those are stable, some of those are unstable, and they'll break down. But just looking at the fusion kind of reaction here, we've got one, and it's the same as the picture on the right here. So we've got hydrogen 2, so an isotope of hydrogen here. Oops. Just get my colors going. Now let's pick it better. It's a little hard to see. So let's go with hydrogen 2 fusing with hydrogen 3. and really easily is fusing together to make one product. So we've got two ones fusing together to make one product here. So we've got 5 on the top, 2 on the bottom, and that's a helium nucleus. So this helium nucleus, if you can see over in the picture, that's this part right here, is actually unstable. It's not going to last too long here. So it's going to decay. It's going to lose a neutron and have an alpha particle given off as well there. But just to show you kind of that idea of fusion versus fission, remember that fusion is taking small kind of elements and fusing them together. Fission, on the other hand, is taking big ones and breaking them apart, often triggered by a neutron kind of hitting it from there. Okay.